If you are a JAM candidate, watch this video till the end. There are two wrong definitions that candidates have about transition elements. Number one definition is that transition elements are d-block elements. Number two is that transition elements are elements that have partially filled d orbital. Wrong. Now here is the fact. Although all transition elements belong to d-block, but not all d-block elements are transition elements. Transition element is defined as the elements that after forming its most stable ion still has partially filled d orbital. I did not say the element that has partially filled d orbital. I said the element that its most stable ion has partially filled d orbital. I'm going to use the first transition series as an instance. Here is one acronym you can use to remember the first transition series. The first three is Scantiva. Scantiva for scandium, titanium, vanadium. The next three is Chromanfe. Chromanfe. Chromium, manganese, iron. And the last four are Conecos. Cobalt, nickel, copper, and zinc. Scandium has the configuration S2D1. Titanium S2D2. Vanadium S2D3. Chromium, instead of writing S2D4, 4 is close to half filled, which is D5, which is highly stable. You have to borrow one from this s orbital and add it to this 4 to make it 5. So the configuration of chromium is S1D5. Manganese is S2D5. Iron S2D6. Cobalt S2D7. Nickel S2D8. Copper D10 is another stable configuration. So instead of saying S2D9, we say S1D10. And zinc S2D10. Now, one thing is common about the first transition series. Their most stable ion is in the +2 oxidation state. That is, when they lose 2 electrons from the s orbital, they have a very stable ion. The exception to this rule is scandium and chromium, whose most stable ions are in 3+ oxidation states. For others, their most stable ions are in +2 oxidation states. Titanium 2+, vanadium 2+, manganese 2+, iron 2+, cobalt 2+, nickel 2+, copper 2+, and zinc 2+. Now, that element whose most stable ion has its d orbital partly filled with electron is regarded as transition element. The one that does not have its d orbital partly filled with electron is not transitional, irrespective of the fact that it belongs to d block. You should always know that the first 2 electrons that are lost from s orbital. Scandium 3+ means that 2 electrons were lost from s orbital and 1 was lost from d orbital, which means the d orbital is empty. So scandium 3 ion having empty d orbital is a testament that scandium is not a transitional element. Now let's go to titanium. Titanium 2 ion, the 2+ here signifies that 2 electrons have been lost from s orbital, meaning that we have d2 remaining. This d2 shows that the d orbital is partly filled with electron. Remember, for d orbital to be complete, it must have 10 electrons. So d2 means that d orbital is partly filled. Therefore, titanium is a transitional element. After losing 2 electrons from s orbital, we have d3 remaining. Therefore, vanadium is a transitional element. Chromium, 3 electrons lost. Out of 6 now, 3 has been lost, d3. So chromium is transitional. Manganese, after losing two from s orbital, we still have D5. For iron, after losing 2 from s orbital, we have D6. Cobalt, of course, D7. So both iron and cobalt are transitional. Nickel, after losing 2 from s, we have D8. So nickel is transitional. Copper, after losing 2, we have D9. So copper is transitional. Now look at zinc. After losing 2 from s orbital, we have what? D10. D10 is fully filled, not partly filled. Therefore, zinc is not a transitional element. Scandium is also not a transitional element. And by this, we now define transitional element as the element whose most stable ion contains partly filled d orbital. Follow and subscribe to my YouTube channel. Bye.